Okay, maybe you'll forgive my chaos. I've changed my background now that we're in Unit 2, might as well run something new. So now for this unit, I'll be running this picture of my daughter in one of our favorite high elevation lakes up in the Sierra. And you'll notice that I'm sharing a screen that has the notes from that previous lecture. I will often talk about stuff, and then if I realize that I babbled a lot, I might in a future video do something like you see on the screen, which sort of lists all the things you should have taken out of it. So in that previous video, I talked about some basic ecology, the difference between food webs and food chains. I don't know that I actually use this term, but we talked about trophic levels, like where you are in the flow of energy, whether you're a producer, a primary consumer, secondary consumer, or you eat primary and secondary consumers. Those are called trophic levels, like where you are in the flow of energy. Trophic stuff is energy flow stuff. I also gave you that rule of thumb that nutrients usually cycle through a system, but energy goes one way. I added an interesting term about chemoautotrophs. And I also used that terminology that we assign for what you eat, like herbivore, carnivore, omnivore, and a tridivore. These are what I think are the really basic candy cane intro to ecology stuff. You might remember an activity like this from your earlier science classes when you were a kid. You might have drawn your own food web. And basically what you're supposed to get from this is how many species depend on each other, how they're all tied together, how the bugs are important because that's what the mice will eat, and how the mice are important because that's what the snakes will eat, and how there's all these interesting connections between the coyote and the deer and the flowers. And if there's no more flowers, there's no more deer for the coyote. Yay, it's a big net. Everybody's connected. There's a famous John Muir quote: when we pluck something out from nature, we find it connected to everything else in the universe, or something like that. If you were a fourth grader, I would pat myself on the back and I would say I've taught you well. But you're more than a fourth grader. So yesterday we started to talk about some species that are maybe more important. We call them keystone species. A keystone is this key architectural element that creates a weird transfer of energy so that all the weight in a wall, instead of pushing down across a beam, is instead transferred sideways to piers. This was a big deal. It was called the Etruscan arch, and it all depends on this one rock. And if you don't have that one rock, the whole wall falls down. Like, if you don't have a sea otter, the whole ecosystem falls apart. Sea otter is a keystone species. For classic, what we would call generic classic ecology reasons. If you don't mind, I'll show you something slightly different. This might be slow, but hey, look, there you go. Classic ecology. If these get hunted down for their fur, these are going to become much more common. Their population will rise, which means these will get hammered. Their population will decline. And it just so happens that these are food for other stuff. And by the way, kelp is also habitat for other stuff. So this is both a trophic issue, and we say it's a trophic cascade when you make a change at one level and that causes a change at another level, which causes a change at another level, which causes a change at other levels. That's a trophic cascade. And by the way, this is also a habitat issue because a lot of stuff eats kelp, so they would be affected here. But a lot of stuff lives in kelp, so kelp also provides habitat relationships to other stuff, things which don't eat kelp per se, but they just live there. All right. That, students, was one example of one keystone species. It's the most famous and most classic one. And it illustrates some vocabulary that you're supposed to know: keystone species, trophic cascade, habitat. Now I'd like to tell you some other stories about some other famous keystone species. These will each illustrate other vocab and terms that are found in your study guide. One interesting species that was driven to extinction by sloppy human activity was sea stars. You might know that there's a whole bunch of different sea star species. Maybe you know this, maybe you don't. They eat all sorts of stuff, but especially bivalves, animals with two shells, like clams and scallops and mussels and stuff with two shells, oysters. It's cool how they do that. They have a teeny little beak, and so they will walk over a mussel, and they use that little beak to like, and they like make a little tiny hole into the mussel, and then with the sea star over the mussel, the sea star will open its mouth and force its stomach into the mussel shell. Like the stomach turns inside out like a dog poop bag. It pours out stomach acid into the mussel, and then the stomach goes inside and digests and slurps up the mussel meat. Stomach goes back into the sea star, and the sea star walks away, leaving an empty mussel shell with a little hole in it. If you walk tide pools, you'll often find bivalves with one little round drilled hole. That's normally from sea stars. There's actually other stuff that does this, but I don't know. I thought that was neat. Right. Sea stars, they eat all sorts of stuff. And, you know, if you're like a scallop diver, for example, you might notice that sea stars are eating the mussels and the oysters and the clams and the scallops. And so a bunch of divers got together and they made a deal. And when they were down there harvesting bivalves, they caught all of the sea stars, and they'd get back to shore and they would fling them onto the sand and feed them to the seagulls to get rid of the sea stars. They were trying to remove a predator of what they wanted. Sea star eats the scallops, so maybe if we get rid of the sea stars, we'll get more scallops. Reasonable thinking. Within a few years, the divers ran out of scallops. You might find this surprising. I'm drawing for you the populations of 4 different species: mussels, clams, scallops, and oysters. Okay. Sea stars eat all of these. One year, if the oysters are becoming really common, well, you know, that's going to mean that they're very easy for the sea stars to find. The sea stars that are really good at eating oysters will have more babies, and so sea stars will gradually lower the number of oysters. And by a predator knocking back one species, it protects the population of the competitors. If clams were to take off, well, sea stars will probably eat mostly clams, so clams go down in number, and that allows mussels, oysters, and scallops to stay in the game. This is called the predator effect. It was first seen in sea stars. I mean, it was first researched and named in sea stars. It's since been seen in many predators. The idea is, if there's a bunch of species that compete with each other, a predator keeps one species from wiping out the others, right? Like if the scallops are doing really well, the sea stars will eat more scallops, and that sort of helps these other guys stay in the mix. It's like monopoly control if you understand economics. The idea goes, dang, if those guys are winning, then they're the most likely to get eaten by the sea star, which lets all the other ones survive. You protect, you might want to write this down. You protect diversity by limiting the competitor's ability to exclude the others, right? That's called competitive exclusion. Competitive exclusion. So a predator will keep one bivalve from outcompeting the others by eating the crap out of that most common bivalve. When the divers got rid of the sea stars, it happened to be a really good year for the mussels. And with no predator, there was no limit to that population. Normally, you would have seen sea stars knocking back a whole bunch of mussels because they're the most common food. But in this part of the ocean, there were no more sea stars. So these mussels had a whole bunch of babies, and then they had a whole bunch of babies. And they kind of outcompeted the clams, and they outcompeted the oysters, and they outcompeted the scallops, all of which became pretty hard to find. They didn't go extinct, but they became hard to find commercially. So the scallop divers all went out of business. By the way, mussel populations continued to grow. And I believe that this was Southern California where this all happened. And there are tremendous numbers of mussels in these regions. And these are very rare because it just happened to be like a good decade for the mussels. And with nothing to limit their growth, they just exploded until they excluded all of their competitors. So the predator effect is to protect diversity by limiting competitive exclusion. Imagine if like AT&T was having a really good year and their network was growing the most, the government would say, yo, we're going to limit the growth of AT&T so that we can maintain a bunch of other cellular carriers so that there's competition in the market and we have diversity of cell phone companies. Right? You would keep one from outcompeting the others to keep a whole bunch of others. Now, predators don't do this on purpose. Predators are just stupid predators. They just eat whatever's most common, but it works the same way. It's called the predator effect. By the way, that's a vocab term, so it's underlined. And competitive exclusion is also a vocabulary term. You should know that one as well. When one competitor excludes the others, one species kicks its competitors out of an ecosystem. So any hoot. Sea stars, blah, 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 blah. Example of the predator effect. Nobody thought they were very important. Scallop divers thought they were doing something smart. Turns out they shot themselves in the foot. This predator effect has now been seen in sharks. Coral reef that has shark will have more total species than coral reef without sharks. Sharks will eat the most common fish, so those fish never get to be so abundant that they exclude other fish. This has been seen with wolves. This has been seen with orcas, killer whales. This has been documented with osprey and the diversity of trout, all sorts of stuff. Okay. I hope you'll forgive me. I got to move on. This is a grizzly bear. That's a salmon getting ready to become grizzly food. Grizzly bears come in all size and shape and color, but one thing we know about grizzly bears is they love to eat salmon. Man, I've been to Alaska. Holy mackerel. Those grizzly bears get so big. And when the salmon are running, those rivers are just red with salmon. Literally, the grizzly bears get into these weird, funky food comas, and the whole state is disgusting. Just gross. Oh my God, I hate grizzly bears. You can smell them from like a mile away. They're really cute on TV, but they smell horrible. They just like waddle down to the river and they just like wait there until a salmon just smacks into them and they go, ah, and they like grab the salmon. And then they like waddle out of the river carrying the salmon like this big girl. Actually, that's a pretty small grizzly bear, but anyway, they carry that salmon. They walk up onto the bank of the river, roll around for a minute. They take the salmon, and it's horrifying to see this. They will use their claws to scrape away the fillet, the part you and I would love to eat. And they will just scrape the fillets, and then they'll chew on the head, they'll chew on the bones, and they'll eat all the guts, the stuff you and I would throw out. It's kind of funny. Grizzly bears hate the one part of the salmon we keep, and we throw out all the parts that the grizzly bears love, but we can't be in the same place because they're really scary. Those grizzly bears eat so much salmon that they get this like weird fish oil diarrhea. And so you'll see like the tail end of a grizzly bear is usually this like messy, chunky, muddy, dirty, stinky red mass of diarrhea mud. It is horrific. And they smell so bad. And they're so just stuffed that they'll like lay on their backs and like chew on the spine of a salmon until they like fall asleep, and they like rub fish oil all over them and the fish starts to rot. And so they'll have like mold and like other critters like running on them, eating all their chunks of salmon that they've rolled over. It is so gross. But, you know, these are really big mammals. So during the salmon season, a big mama grizzly bear has to put on like, I forget, like 6,000 calories a day or something. Like the numbers are staggering. Okay. There used to be grizzly bears all over the western United States because there used to be salmon all over the western United States. As a matter of fact, the Santa Barbara mission was going to be in Montecito, but the Spanish colonialists that came up here to start the mission system kept getting eaten by grizzly bears. So they were like, oh, Montecito looks nice, you know, 3 big creeks with a bunch of trees around. So they wanted to build it there, but the grizzly bears came and they ate the first scouting party. So the second scouting party came along and went, oh, this looks good. And somebody's like, hey, wait, do you think those are the remains of the first scouting party? And then the grizzly bears ate them. And then the third scouting party came up and they like found all these human entrails and like gold helmets and like crosses and stuff. And they were like, oh, this might be a sketchy spot. Let's go a little bit further. And so they had to build their mission in a big sloppy wetland, the Santa Barbara mission where it is now, because that's the only place they could get away from the grizzly bears was one little coastal wetland swamp that was far away from water. That's why they had Chumash slaves to build the aqueduct for them. Quite an atrocity there, by the way. Anyway, grizzly bears are scary. They used to be all over the western United States. And, you know, as YD came west, we were like, oh, look at all this nice water. And like, oh, wow, look at all these nice trees. But holy crap, those big, scary grizzly bears, they'll eat your baby. So we shot them all. We shot the grizzly bears like you would not believe. We just wiped them out because they're scary. And, you know, you can't have a logging camp if the grizzly bear keeps eating all your loggers. Perfectly reasonable. I would have done the same thing. And we killed all the grizzly bears because they kept eating all the loggers. And we successfully exterminated the threat. And we protected our logging industry. And the loggers were happy and they could go cut down the trees. And they were safe while they did this. And within a generation or two, the trees stopped growing. Because as it happens, when a grizzly bear eats a salmon, that's a whole bunch of nutrients coming up the river, and the grizzly bear takes all of those nutrients out of the river and walks up the hill and starts to scatter those nutrients all over the land. And if you do the math, all those grizzly bears times all that salmon times all that land, check this out. Here's a shocker. The guts of the salmon plus the grizzly poop, if you combine that, is the largest dose of fertilizer on Earth. You know, nutrient cycling. All these nutrients that would have flushed out to the ocean are moving uphill in the salmon, and the grizzly bear takes them out of the river and up onto the hillsides. Nutrient cycling. And here's a crazy thought. You get rid of the grizzly bear, you stop fertilizing the trees stop growing, the entire ecosystem that eats the trees is now out of food. That's basic trophic level stuff. But also, that forest is habitat. This impacted humans, this impacted owls, this impacted salamanders, this impacted other species in the rivers, it impacted all sorts of songbirds, all tied to the grizzly bear. The removal of the grizzly bear was a nutrient cycling keystone species. And by the way, secondarily, the trees are a habitat issue. You like what I'm doing here? You get rid of some species and they make a big old difference. You know, if you get rid of these lodgepole pine trees, honestly, I don't know, man. They're not habitat for much. I guess it would change the ecosystem, but I don't know if it would be huge. Get rid of the grizzly bears and the entire Northwest forest stops growing. That's a big whoop. These little things are called prairie dogs. Prairie dogs are kind of neat. Prairie dogs eat seed sprouts. But here's the thing. They harvest the seeds and then they farm the seed sprouts. If you don't think that's neat, you're not paying attention. A prairie dog will go out, gather a whole bunch of seeds, stuff them in their mouth, and then they like run down into their hole. And they do that thing where down the tunnel, they've got one room that's perfectly dry. And so they leave the seeds in there, organized, carefully, dry. And then every day, the prairie dog will walk over to the silo, take out a handful of seeds, stuff them in his mouth, walk over to the other tunnel where it's wet, and lay out those seeds so that they'll sprout. And when those seeds start to sprout, that's what they eat. They farm seed sprouts. And if you don't think that's cool, you can just get out of my class right now. Now, when Whitey was manifesting destiny out westward, we found the American prairie, massive, endless fields of grain, unbelievable grasslands with soil that was unparalleled. I mean, truly, America's the greatest nation on earth because we kind of have the sweetest chunk of dirt. The prairie has the best topsoil because the grass. But if you want to run cattle, those cattle might enjoy all that grass on the prairie until they step into a prairie dog hole and then their leg breaks. And you all know what you have to do to livestock that has a broken leg, right? So here's a crazy thing. We, of course, got in the habit of shooting all the prairie dogs. But fun little detail, if you're into American history or if you're into guns, this is a pretty fascinating overlap. When the prairie dog are out gathering grass seeds, they always have a lookout. And the lookout stands up and makes a chirp to warn the others if it sees a bird. So there will be like 80 prairie dogs out on the prairie, and then there will be the one that's standing up watching for a bird, and he goes chirp chirp chirp, and everybody goes, oh my god, a bird, and then they all run away, right? The lookout. There's a very small rifle round called the 22 LR or 22 long rifle. It's a really, really cheap, small type of ammunition. They're like tiny, very inexpensive. And back when we were manifesting destiny, whenever a kid turned 4, 5, 6, you'd give them their first rifle. It would be a small kid-sized rifle in this caliber, which has very little recoil. It just goes, and like it shoots this teeny little projectile, but they aim pretty well. And so you would train kids to shoot the lookout. Because when you shoot the lookout, another prairie dog will be like, we don't have a lookout, and they become the lookout. So you shoot that one, and then another prairie dog will be like, what? No lookout, and then they pop up. Whack-a-mole used to not be moles. It used to not be a hammer. Back in the day, we trained a whole generation of children to be expert marksmen so that we could exterminate these things because they kept ruining the legs of all of our livestock. So we said, here you go, little Jimmy, take your rifle and your 500 rounds and go shoot all the prairie dogs. And the kid got so good that when the fair came around, the kids would take the rifle with them to the fair. And at the fair, you'd have a competition for all the local kids. Whoever's best at shooting prairie dogs gets this coffee mug or whatever, stuffed bear. And this evolved. When the prairie dogs became less common, you would have the kids shoot little cutouts that looked like prairie dogs. When the kids weren't allowed to bring their rifles anymore, you would use pellet guns. When pellet guns got too dangerous, they started to use pressurized water. When the pressurized water was too difficult to travel around America, they just started to use mallets. And this is the evolution of whack-a-mole. Comes from the period when we exterminated these things. By the way, that period of time also created a generation of Americans that were pretty good with the rifle, giving us a military advantage during armed conflicts that followed. And they made the 22 long rifle the world's most popular rifle cartridge and the most popular rifles. Is this not neat? Anyway, prairie dogs. They churn the soil. They dig these holes. They stuff a bunch of seeds in the ground. And as it happens, When you get rid of all the prairie dogs, you protect the cattle, but the grass stopped growing. Hey, surprise that you get rid of this thing to solve the one problem and the whole ecosystem falls apart. It's a keystone species. In this case, for a bunch of reasons. First of all, stirring up the soil is nutrient cycling. Second of all, there's a whole bunch of species that live in those burrows. So like badgers and burrowing owls and cool jackrabbits all have become rare or extinct since they no longer have another species to dig their homes. But most importantly, the diversity of the American prairie went downhill because in any given year, there's a whole bunch of different grasses. This might be a good year for the wet ones. Next year might be good for the dry grass. Next year might be good for that grass that tolerates the heat. And the only place that you have significant reservoirs of all these grasses is in the ground, in the burrows of the prairie dogs and in their poop. So they maintained the diversity of grasses just by the way that they ate. And by getting rid of the prairie dogs, there was nothing to stash the seeds. So after about 20 years, it would be a hot year and there was no more hot seeds left in the soil. And then it would be a dry year and there was no more dry stuff left in the soil. By the way, this led to the Dust Bowl, which led to the Depression. I just think environmental science is neat and history is neat, and sometimes they overlap. Whatever. American alligator makes some pretty expensive shoes and briefcases, I guess. And, they're scary. They'll eat your baby. So, Americans in the South, we shot all the alligators and we made leather belts and leather briefcases and leather shoes and leather wallets, I don't know, purses, stuff out of alligator skin. I don't know. Alligators are kind of neat. Sorry. The way that an alligator eats is an alligator will bite something really big, but once they've bitten it, they can't start eating it because they've got these stupid little claws down here, and they got like 1,000 teeth up there with like no real useful tongue. They've got this teeny little itty bitty tongue and these massive chompers and these stupid little feet right here. So when an alligator eats a big stork like you see on the screen here, the alligator can't swallow it. The alligator has to roll around to break all of its arms, and then the alligator will drown it. After they drown it, they stuff the carcass in these underwater caves called gator holes. Underneath the ground, there's these tunnels. So stuff your broken leg deer or whatever into the gator hole. That right there is a gator hole. This is all water. And that is a gator hole. Okay. You leave your carcass in there, and as it rots in the water, the alligator can come and pull off pieces like pulled pork or like shredded meat or whatever. The alligator can come and take little chunks of meat off the rotting carcass. That's cool. We killed all the gators because they make belts and shoes and because they're scary and they eat your baby. With no alligators left, all of these holes eventually filled up. And here's a crazy thing. When you've lost the flow of water, sediment flow eventually fills up all of those ponds. With an alligator, water flows so the sediment goes out to the ocean. Without an alligator, water doesn't flow, and the American bayou disappeared. All the ponds filled in, and they became grassland. where fire spread more quickly when there would be lightning strikes, and the entire ecosystem disappeared because there was no more alligators. Hey.
Please log in through the Google Home app.
So, interesting pattern where the alligator actually builds the environment. That's called an engineer species. Alligator builds the environment, engineer species. Without the alligator, you don't even have the system itself. The physical reality of that landscape is changed because the activity of that one species maintains your landscape. Engineer, like builder, like it does something. By the way, there's all this interesting stuff about how the water was so dependable over such long periods of time that all these species had evolved to benefit and migrate through the bayou. So the loss of this affected ducks that live in Argentina and Canada and stuff. Anyway, you can take some stuff off this slide. I'm almost done, I swear. Beavers build dams. By the way, I'm running low on time, but these dams have air conditioning and nurseries and bathrooms and heating. I swear. They pack rotting plant material into one room so its decay will give off heat, and then they put the babies on top of that so the babies have heating. And they use convection currents so that the living room has air conditioning, and the bathroom is at the end of the hall. I swear, so they don't have to smell their poop. Anyway, beavers build ponds. And so this is another example of an engineer species. We shot them all because they have decent fur. They lost all the ponds. Then the ponds means there wasn't any more fish or any more ducks, which really affected our food supply in the Sierra. By the way, that also affected our water supply because those ponds allow for the recharge of groundwater. And I got just one more. I know, this is a really long video. It's one of the longest of the year, but I just love ecology. I'm sorry, I gotta do this. I got one more. That is the gray wolf. And the gray wolf turns out to have so many impacts on so many species that it actually is its own thing. We call it the wolf effect because it's so complicated. Wolves are amazing, they're majestic, they work in groups, but they're courageous and they survive in really harsh environments and all this amazing stuff. They're like a fundamentally American thing. But they'll eat your sheep and they'll eat your babies, so we shot them. I'm cutting to the chase here. We got rid of the wolves because they're scary. And basically getting rid of the wolves completely changed the middle of the United States. The example is important because of the details. The pattern is obvious by now. Recently, we reintroduced the wolves back into Yellowstone National Park, and reintroducing wolves completely revived the ecosystem in ways that are shocking. I'll explain. This is an elk, and that elk is not normally chilling in the water. It's not normally chilling in the water because in the water you would usually be visible. Maybe if you're a hunter that all prey needs water, so the best place to wait for your prey is near the water. Wolves are evolved to know this. So the wolves would usually be lurking in that grassland, and when the elk run across the grass to take a quick drink of water, then they run back to the forest, the wolves will pick off grandma or the little baby elk or whatever. Normally, elk live in the forest, they run across the meadow to take a quick drink, and hopefully they all make it back to the forest, minus the straggler that became wolf food. You can see that this elk is not afraid, because he's just chilling in the water. As a matter of fact, I can tell that this elk and other elks have spent a lot of time in this stream. I can tell because there's no vegetation along the river. Usually there's plants that grow along the river. Vocab term that you should know, that's called riparian vegetation. Vegetation that grows along the river, riparian. And that stuff is always green because, you know, the roots are in the river, right? So even if that grassland was all dried out, there should be a buffer of green stuff right along the edge. There also should not be this big muddy slide where the elk go in and out, but with no wolves around, the elk's behavior is different. They basically lay in the river, drink water, eat any sprouts they can find. They've ignored the forest. What's interesting is in the absence of the wolf, the behavior of the elk changes. So their diet shifts. They end up eating all the riparian vegetation instead of eating little baby trees in the forest. And now the whole river is different. Without riparian vegetation, the river is hotter, right? Because riparian vegetation would shade the river. Without riparian vegetation, the river is hotter and it's dirtier because there's nothing to stop mud from eroding into the water. So the water is cloudier and hotter. So now there aren't insects in the water because they can't lay their eggs in the rocks or something, which means there aren't trout in the river, which means there aren't bald eagles to eat the trout. What's interesting is riparian habitat is a really good place for songbirds to live because they can hide in the vegetation and they can eat the insects that are normally there. Without the riparian vegetation, there's no songbirds. Crazy thing is, when you put the wolves back in Yellowstone, it just changes the behavior of the elk. Technically, their population size goes down a little bit, but not a lot. But here comes the nutty stuff. Once the elk are afraid, they go back to the forest and the riparian vegetation comes back. When the riparian vegetation comes back, the river gets colder and clearer. Now insects show up, lay their eggs, feed the fish with their eggs. Some of those insects survive. They pollinate all sorts of flowers, so flower diversity goes up. With more flowers, there's more insect diversity. There's more butterflies in Yellowstone when you add the wolves. That you should just Google this because I can't remember all the craziness of this, but basically 300 some species of butterflies are more common. All species of fish are more common. All kinds of songbirds are more common and predatory birds are more common. There's more small mammals. There's more amphibians because they've got more food in the river. Like the entire park has greater diversity. It's more productive. There are more sounds and more smells and more things to see because wolves are back and the elk are scared again. This is so complicated that it's just called the wolf effect. You should really Google this sometime. And here comes your last slide. We call these things community level interactions. They are all the different ways that species are connected. In the 4th grade, we tell you food webs. Okay, 4th graders. But you know, now that you're stepping up to be like college kids, it's not just food webs anymore. Now that you're stepping up to college kid level, there's other types of interactions within a community. It's not just the trophic stuff, but there's also the habitat issues, like the way that the kelp is a place for other stuff to live. There's nutrient cycling, like the way that the grizzly bears fertilize the forest or the prairie dogs mix the soil. There's engineering species, which create their environment by their activity. So dam building is something that the beaver does for themselves, but it creates the entire river ecology of the Sierra, same as alligators build the American bayou. There's the predator effect, where predators eat whichever prey is most common and keep that prey species from outcompeting the other prey species. There's all sorts of stuff about evolution, and there's that wacky thing about wolves. Some species are really important. Entire ecosystems can fall apart. And you'll notice there was a common theme in all my stories. We didn't see it coming. We made logical decisions to change our environment to benefit us. Those would look really good on my head. Those are scary. Those are eating my food. Those are killing my cows. That would make some nice shoes. I'm cold, and that makes a heck of a jacket. Wolves are scary. They eat my babies and my sheep. We made logical decisions to change our environment to benefit us. And we often find when we do that, that the relationships between species are more complicated than we thought. It's not just food stuff. There's a whole bunch of community level interactions, other ways that species affect each other. You may want to rewind that. You may want to write a couple more things down. This was one of the longest videos of the year. I apologize for how long it was, but I swear that one is done.